This is question 20 from a Methods Unit 2 paper, calculator paper, and it's a practice paper. The question is looking at a 3D object, and it's made up of a hemisphere, that's half of a sphere, hence the northern hemisphere and southern hemisphere when we refer to the world, and it's on top of a cone. It tells you the dimensions of the cone has a diameter of 10 centimeters, height of 12, and those are indicated on the diagram. And it's asked you to work out the total surface area of the shape. Now, on the formula page, you're given the surface area of a sphere, and you're given the curved surface area of a cone. That's in the inside cover of the exam paper. So we're going to need to use those. The important thing to look at is what do we need from the to use these formulae. So we're going to need the radius. Now if you look up, we're already given the diameter, so the radius is going to be half of that, which is 5. So we got r equals 5 centimeters. If you look down at the curved surface area, it refers to r and l. Now r is okay because it's exactly the same as for the sphere. Our r is 5. L is the slanted length of the cone, and you'll see that we're given h. So we've got h equals 12, we've got r equals 5, but we don't know what L is. However, if you draw L on, R, H and L form a right angled triangle, so we can use Pythagoras to work out L by doing 12 squared plus 5 squared and then square rooting it. So that means that L is the square root of 144 plus 25, and that's the square root of 169, which is 13. So L is 13, and now we can start to use these two to work out our formulae. So first of all, I'm going to start with the hemisphere. So we've got the curved surface area is 4 pi r squared. Now we're going to need to divide that by 2 because we're just working with a hemisphere, and the easiest way to do that is to just work out 2 lots of it instead of 4 lots of it. So that's our surface area for our hemisphere. So that's 2 times pi times the radius squared. Now for our cone, we're going to need to do pi, r and l. So that's pi times the radius times our slanted length L. If we work those two out, we've got 2 pi times 5 squared. So this one here is 50 pi, which would be 157 point whatever, but I'll leave that one for the moment because I'm now going to do 5 times 13, which is 65, so I have 65 pi. Just leaving them in terms of pi because it makes my calculation a bit easier, because the total surface area is going to be these two added together, and that's going to be 115 lots of pi, which means I can just do 115 times pi, and it tells me that the total surface area is 361, and that's my answer because I leave it to 3 significant figures. But just to be thorough, I'd always write out my calculator display and then do my final answer as 361, and if we look at it, the units are centimeters squared because we're finding an area.